Hello and welcome, everyone. I'm Jim Olson, Assistant Executive Director of the NTCA, and thank you for attending today's webinar. Today's webinar is titled Going Curbless, and it's sponsored by the Noble Company. Before we begin, I have a little business to take care of. Today's webinar will be muted. Please use your participant feedback or chat screen on your computer to ask questions. Type them in, and we will answer them at the end of this presentation. All of our webinars are archived and available to watch at any time after the webinars are presented. Please email your request to me, Jim Olson. I will provide my email address on the chat screen when we begin. I will then send you the archived version after this presentation is completed. If the audio on your computer is poor, call the number on the chat screen to listen on your phone. Okay, here we go. Today's speaker, Dean Moylanen, is a Division IX waterproofing, crack isolation, and permeation specialist who advises on some of the most demanding and prestigious projects in the United States. As a 30-year veteran of the industry, Dean's relationships with architects, builders, and owners allow him access to some of the most challenging and compelling design issues in the industry. Dean's extensive career on job sites give him a real-world perspective as he has seen firsthand success and failure relating to product selection, installation issues, and sequencing challenges. Welcome, Dean.
Thank you very much, Jim, and I always appreciate being part of these NTCA events. Before I get too much into my presentation, I just wanted to give a shout-out to NTCA. I feel grateful and blessed that I am an NTCA ambassador for the state of Nevada, but because I run around the country doing lots of architectural presentations, I do try to preach the message that qualified labor is the future of quality installations in our industry. So whether you're a tile contractor or an architect or specification writer, if you need any information with regard to having qualified labor be a part of your projects, or if you'd like to be a contractor who avails himself of those accreditation opportunities, I'm sure you can reach out to NTCA or to myself. We'd be glad to help you. I also wanted to let folks know this is an AIA-approved session. Meets all the guidelines for your architects and for your designers who need those educational credits. By all means, this meets those requirements. And if you need any additional support, please contact Tony Perfect at tony@noblecompany.com. That's T-O-N-I, not T-O-N-Y. And we'll be happy to make sure you get your required credits for being a part of this session today. I also wanted to give a shout out to some friendly competitors in the industry. This presentation originally was a collaboration between Noble Company, Laddercrete, and Schluter. We did this at the Coverings event, and it really was enjoyable. And so you're going to see a lot of different images that may reflect different company products and procedures. Please realize there's just general recommendations. You'll always want to source your particular product or manufacturer most applicable to your design requirements. Having said all that, let's kind of jump into this. Curbless showers, curbless wet areas are definitely a strong trend in our industry. You want to make sure you're availing yourself of all the information required and necessary before you jump in and offer this type of design scheme to your customer, or if you're designing this type of design scheme for your project. We're going to take a look at some current industry standards, their impacts on these shower systems. We want to make sure that you understand the difference between a barrier-free and curb-free shower environment. We'll go through some of those explanations. We'll look at some ways to approach your installation methodology and what's required to have a successful curb-free, curbless wet area environment. Obviously, when you're done with this presentation, you'll be armed with the information to pursue this type of wet area environment with confidence and being able to source the information you need. Now let's get into a couple definitions to avoid any confusion, you can have a curbless shower that may or may not be barrier-free. And the reason I bring that up is because I've seen some well-intentioned tile contractors, builders build a curb-free, curbless shower and misrepresent that as a barrier-free environment when in reality they can be somewhat related, but there are some significant differences. For example, you can have your ceramic tile, natural stone, curbless, curb-free shower be barrier-free, or it might not be. By the same token, many barrier-free, aging-in-place shower environments have no ceramic tile or natural stone whatsoever. So it's important to know some of the distinctions to make sure you're giving the client what they want. So real quickly, on the curbless side of the equation, it may look simple. Gee, I'm just taking the curb out of the shower. In reality, as they say, the devil's in the details. But if you look at the barrier-free part of the design element, it's quite extensive. It goes far beyond just eliminating a curb. There may be steps. Those can't be there. You have to factor in, is there going to be enough maneuverability in that space? If someone's in a wheelchair, if they're in a walker, can they get around that shower? Can they access all of the controls, the hot water, whatever they need? Are the shelves placed where they can access the various cleaning items they'll need for their shower experience? These are some of the issues that are involved in a barrier-free design environment. And as you can see, there are some ADA standards for barrier-free. You may want to avail yourself of that information just so you don't misrepresent what you're trying to do for your client. Just looking at a couple details here, obviously, with a curved shower, and we're going to, it's kind of like spring training. Many of you may know this, but let's make sure everyone's on the same page. The curb is essentially put there to keep the water within the shower environment. It has to be stepped over, obviously. In years past, it often had a loose-laid shower pan membrane system with a mortar bed on top of it. With the evolution of shower pan waterproofing techniques, more typically an ANSI A118.10 bonded membrane was attached to the surface of the mortar bed, but nonetheless, it always had a curb at the front of the shower. With curbless entries, that curb is going away. But there's far more that has to be reviewed and analyzed if you're going to have a successful curbless entry and curbless shower system for your project. Now, what's driving the curbless trend? Well, it kind of breaks down into generational motivations amongst the youngsters out there, the millennials. Oftentimes, the design perspective, the aesthetic, the look, the lifestyle appeal of a curbless shower, the way that's going to look in their home, their condo, drives their motivations. As you enter into the boomer part of the equation, the demographic, much more focused on health, safety, welfare. You may have a mother, an in-law, a father, and maybe you, who doesn't want to step over that curb, doesn't want to have that obstacle in place. There may be a wheelchair or walkers involved where safety and functionality become the key drivers of why you would want a curbless shower. Now let's just take a couple of images here. Obviously, when you remove the curb from your shower environment, it opens up a wealth of possibilities. You can go from that traditional square, rectangular, box-like shape. You can start to add radius curves. Obviously, with the removal of a curb, it really opens up the use of what kind of ceramic tile or natural stone can be used. As you can see here, very creative attention to detail with regard to the finishes on the left-hand slide. On the right-hand slide, you see where the feel, the aesthetic of the wet area moves outside of the shower into the entire bathroom experience. So these are some of the things that can be opened up as far as design concepts when you remove the curb from your design environment. Obviously, again, When you look at the boomer demographic, right now I think a lot of you are aware there's just an explosion in assisted living facilities. And oftentimes the residents of those facilities are going to be in wheelchairs, are going to need some type of assistance getting into the shower, so a curb is just not an option. As you can see here, in this case a linear drain was used, and it was placed where the curb was. Real important to note here, if you're going to follow this type of design scheme, you're going to have slope to drain on both sides of that linear drain to make sure you facilitate the most efficient movement of water to that drain area. Again, looking at what opens up when you go with a curbless shower concept. On the slide on the far right, left-hand side, you'll see there's not one but two deluge showers. And these drop an enormous amount of water on the floor in a very short time. They're very popular in the high-end hospitality market, but we are seeing them make their way into higher-end remodel projects and custom homes in the residential sector. And obviously, if you're going to have, in this case, two rather large deluge showers dropping that much water onto your floor environment, with a curbless design scheme, you have to make sure that water finds a home in the right area. So as we go along this presentation, you'll start to realize your waterproofing concerns are going to be greatly extended when you go with the curbless design feature. In these other slides you see where, once again, it's a design, there's form and there's function and there's design perspectives. When that curb is removed from the wet area environment, it opens up a lot of possibilities as far as what you can use. Here you obviously see a very creative mosaic used in the wet area, either a natural stone or a plank type ceramic tile being used outside of that area. Once again, if you're going to be using a curbless linear drain, especially where the curb was, you have to factor in managing that water that's going to extend out beyond the shower area. All right, so let's get into some basic design considerations. For many of us who have been involved in typical wet area shower applications, the center drain, clamping ring drain, typical two-piece drain that's been around for decades, is still often used in many typical shower applications. Now, when you take that curb out, obviously water is going to migrate to areas you don't want it to be typically. So one of the ways of addressing that is with a linear drain. You have to make that determination early on, because that's also going to influence your choice of ceramic tile or natural stone. Now, a new term that's entered into the equation, dynamic coefficient of friction, DCOF. This is the new way of identifying is the ceramic tile or natural stone I'm using going to be slip resistant enough. The old measurement was just static coefficient of friction, or COF. And the big difference between dynamic and static is dynamic actually measures the resistance when already under motion. Static coefficient of friction just measured what it took to get something to move on a surface. And so very important part of your selection process, you want to make sure what you put on the floor is going to be safe. Waterproofing concerns, obviously, there are a variety of methods of waterproofing these areas. Depending on what type of drain you use, that could also influence your waterproofing selection. Let's take a look at some of the impacts of a center drain or clamping ring drain type of assembly. And you see it here in a curbless format. Typically, with this type of drain selection, you're going to be limited in the size of tile you use. Most often it's mosaics, 1 by 1, 2 by 2, maybe 3 by 3. If you get much larger, to create the adequate slope to drain required, usually you're going to have to start cutting up that tile, and that usually creates a rather jarring aesthetic. It can take an otherwise beautiful ceramic tile or stone selection or design element and really disrupt the look and feel of that because you're making so many cuts to make sure the tile gets down to the adequate slope to drain. And besides that, this is the sheer difference between gallon per minute efficiency of a center drain as opposed to linear drains may drive your choice as well, because typically center/clamping ring drains are not going to take water off the floor as quickly as a linear drain. Now, when a linear drain comes into play, obviously you see that you have a variety of options of where you can place that linear drain. We saw a couple slides earlier where the drain was located where the curb was. Sometimes, for aesthetic reasons, it can be placed in the middle of the shower floor. Oftentimes, it's placed in the back of the shower. Now, these choices may be driven by some very practical considerations, especially if you're doing remodeling or trying to control your plumbing costs. You know, where do the existing plumbing lines run now, and what kind of extensive reworking of the plumbing is going to be required to put the drain where you want it. Typically, again, most linear drains are going to take water off the floor much more efficiently. For example, your typical clamping ring drain can run from 3 to 7, maybe 9 gallons per minute at the most. Linear drains start at about 9 gallons per minute and can go up to 32 gallons per minute. That's an incredibly efficient movement of water to where you want it, down the drain hole. Also, too, please be aware, the majority of linear drains on the market are stainless steel. The majority of linear drains that are stainless steel are not marine grade. That may or not make a difference to you, but in certain assisted living and healthcare environments, marine grade may be required. In some high-end hospitality, they may be required simply because the routine cleaning and maintenance, not to mention, without getting too granular, the various oils and potions and lotions that come off the human body can be quite destructive to stainless steel over the long haul. So please be aware those impacts, they may drive your linear drain solution process. There are some linear drains on the market now that have ABS or PVC drain bodies to minimize those concerns. Here we see kind of old school photo on the left-hand side, a typical center or clamping ring drain with a very small 1x1 mosaic. Now, to each his own, but in general, this is kind of a really tired look. It kind of reminiscent of your high school gym, 1968 maybe, 1972. So using linear drains in these applications really opens up what you can use as far as the size and look of your ceramic tile or natural stone. Again, please be aware that with static coefficient of friction and dynamic coefficient of friction, you really have to get your finger on the pulse of what's going to be adequate. Typically, let's take if you had a tile or stone that was 0.6 static coefficient of friction, and realize with that old school measurement system, you had both a dry and a wet measurement. Well, a 0.6 translates to about a 0.38 with dynamic coefficient of friction. Well, what does that mean relative to anything? Well, let me toss out a number that might be helpful. Any ceramic tile or natural stone that is 0.42 or lower with dynamic coefficient of friction is for dry areas only. You have to get above 0.42 with dynamic coefficient of friction to be used in a wet area. Now, one of the appeals of the dynamic coefficient of friction measurement system, there are portable devices that can allow you to measure dynamic coefficient of friction in the field. Just as a little sidebar, the least skid resistant, the most slippery surface out there in wet area is polished granite. Okay. Now on the slide on the right-hand side, you can see where a very harmonious design scheme in which the ceramic tile or natural stone used in the tub area and probably flowing into the drying area is the same tile or stone being used in the shower area. So again, with a linear drain, you can pitch your slope on just one direction, one angle. In this slide, you can see where you can barely see that linear drain up against that far back wall. Of course, it would be very critical to make sure you have the correct slope to drain, 1/4 inch per foot, through that linear drain. And here we're seeing, again, let's go, it's important enough, let's kind of go over this again. Static coefficient of friction, 0.6, equals dynamic coefficient of friction, 0.38. You don't want to be involved in a slip fall liability lawsuit. So just toss out static coefficient of friction measurements. They're no longer relevant. Here you see the actual testing device that's used in the field to provide real-time results of the testing. But again, wet areas have to be higher than 0.42, and if it's below 0.42 or lower, it has to be a dry area. Now, obvious to many, but let's repeat this. Whatever tile or stone you select that may have the appropriate number for wet areas, over time is going to change. Oftentimes, the particles, the ingredients that can cause a tile to be suitable for wet areas over time can be worn down or filled in with soap scum or cleaning agents. So just because you pick the appropriate tile in 2018 for your wet area, you may have to go back and review that as part of your maintenance servicing schedule to make sure, especially in hospitality and public areas, that tile or stone continues to offer the level of performance you need for a wet area. Now, when it comes to waterproofing and methods of creating harmonious, successful tie-in from the linear drain to the waterproofing system, there are a variety of ways you can accomplish that. There are polyethylene, PVC, CP sheet membrane systems. There's liquid, fluid-applied membrane systems, and they attach to linear drains or to clamping ring drains in various fashions. In this instance, we see where a hot glue tag from the linear drain is shingle overlapping over a PE polyethylene sheet membrane on the floor surface of the shower. Bonded drain flanges have become popular with a variety of manufacturers. Typically, they have a polyethylene sheet membrane that's being bonded on top of the flange area with a thin set product. Again, make sure you source each individual manufacturer for their particular requirements, but we're talking general concepts here for waterproofing. Of course, fluid-applied liquid membrane systems have been around for decades, and they are also used in conjunction with these linear drain installations. In this case, you see where, and typically they're either roller-applied, brush-applied, but be very cautious because some manufacturers require multiple coats. Some manufacturers have drying times of several hours. Some may require a couple of days. Make sure you check with that individual manufacturer to make sure, do I need a reinforcing fabric or not? But essentially, that liquid membrane makes a transition from the substrate to the flange of the stainless steel linear drain. And, of course, after the appropriate curing time, you can do your flood test and, of course, continue on from there. One important distinction, and I bring this up in my other continuing education seminars, with regard to waterproof membranes, please make sure that you look at the crack isolation properties of that waterproof membrane. I see where more and more architects and specification writers will reference ANSI A118.12 as part of the requirements for a successful waterproofing system. To get a little more detailed, if you look at ANSI A118.12, there's a standard performance metric of a 1/16 of an inch. There's a high performance measurement of an 1/8 of an inch. Of course, your major concerns, typically what I see when I'm on jobs, we see some challenges with waterproofing, where that shower pan meets the wall and you have a plane differential, two different substrates. Oftentimes there's movement that can be disrupted to a membrane system. where you have, especially with linear drains, 4, 6, 8 lineal feet of waterproofing, that transition point from the substrate to the stainless steel flange can be a challenge. So make sure you look at which system is going to best suit your requirements as far as performance. And here you see typical detail. This could be anyone's liquid membrane, but typically with a liquid membrane system, you're going to have a single pitch of dry pack mortar. The membrane is going to be installed on top of the dry pack mortar bed. It will flash over the flange of the stainless steel linear drain, and of course, tile or stone is going to be installed. Now, very critical, flood test always. I can't repeat that any more strenuously. 2 inches, 24 hours is the ASTM required flood test norm. 2 inches, 24 hours every shower to make sure you have a successful waterproofing installation. Now, as part of the evolution of waterproofing with linear drains, there are a variety of manufacturers who have gone towards taking that clamping ring drain concept and applying it to linear drains. When this is used, typically you have a sheet membrane system. Could be polyethylene, could be CPE, chlorinated polyethylene, but that sheet membrane is mechanically fastened to the drain body and then additionally secured with a high-grade marine sealant. That compression concept is the same concept that's been used for the last 50 years in clamping ring drains. It provides a very robust attachment from the waterproof membrane to the drain body. And here we see a typical detail of that type of installation. Again, ANSI A118.10 bonded membrane on top of the mortar bed, attaches to the drain body, is secured by a clamping ring with an additional bead of marine-grade sealant that provides a very robust compression gasket effect at that transfer from the substrate to the drain body. Very important to mention at this point, there are some linear drains out there, much like clamping ring drains, that were designed for use with a loose-laid waterproof membrane system. So when you're making your selection, please be aware that that drain may require a loose-laid system. And of course, with that system, you're going to double the amount of mortar because you'll have your pre-pitch mortar bed, then you'll have your loose-laid membrane, then you'll have another layer of mortar on top of that. Of course, nothing wrong with that detail, nothing wrong with that method, but just be aware, your linear drain may require that. There are a few linear drains out there that can actually handle both of those waterproofing design schemes. Again, the devil's in the detail. Make sure you check to make sure that you've got an adequate waterproofing system that is compatible with that drain system, okay? Going on to our next slide here, we mentioned previously, when you're waterproofing for a curbless design system, the waterproofing concerns are going to extend well beyond the typical wet area. My basic rule of thumb when I meet with architects, specification writers, owners, is that the entire drying area of the shower, of the bathroom, becomes a wet area. Because even with the most efficient use of a linear drain, water is going to get outside that shower environment. It's going to get close to stud wall cavities, and that is your biggest concern. If you bring the membrane out into the drying area, you're going to have to flash up the walls to make sure water can't migrate into stud wall cavities. That is the area of greatest concern, because if that happens, you're going to have microbial growth and water ponding areas where you can't see it. So very critical. We've been on some projects where, unfortunately, that wasn't made clear to the tile contractor, wasn't made clear to the architect or specification writer. Those areas outside of the shower in the drying area now become wet areas. Going on to our next slide, you see a typical detail here. If you're using a bonded flange membrane system or a typical clamping ring drain system, this would be your detail. Now, show the high point existing as it extends out of the shower into the drying area. Of course, the question remains, once you get outside of the shower area, are you going to have to slope your substrate? Well, that will depend on whether or not you have additional drains outside of the shower area in the drying area. And you'll see in a couple of slides where sometimes that may be an option that you would want to pursue based on the usage and the amount of water getting out of the wet areas. Let's go back to linear drain placement because it is critical. If at all possible, try to put the linear drain on the back wall, because when you do that, you slope in one direction, it's away from the drying area, but of course your existing plumbing, or if it's new construction, where the plumbing is designed to be located is going to play into where you place that linear drain. It may behoove you to put that linear drain in the center of the floor. Again, if you're going to do that, make sure that your substrate is pitched in both directions towards that linear drain. We can see at the very bottom of the slide a tile-topped linear drain strainer. This is a very popular concept amongst a variety of linear drain manufacturers in which the matching tiler stone, sometimes a contrasting tiler stone, is put in place of the strainer on a linear drain. Well, when that happens, please realize, regardless of the drain manufacturer, you are going to significantly reduce the amount of water that can flow down through that drain. We try to make that clear to owners, contractors, architects, designers. Oftentimes, someone's design scheme will carry the day, and obviously you can use a tile-top strainer, but just realize it will significantly reduce the amount of water that can efficiently flow down that linear drain. All right, so we already talked about defining the wet area space. I can't stress how critical that is. That's not something you want to discuss after the fact when you're already on the job. It should be well defined before any construction takes place, exactly what area is going to be waterproofed. Of course, again, a curbless shower means the entire bathroom is now going to be a wet area. And gallons per minute becomes a very important metric. Again, typically linear drains will have a much higher gallon per minute performance than a clamping ring drain, but be advised that there's a huge variation between manufacturers. And again, if you use a tile-top strainer, that's going to significantly impact the efficiency of that drain. Okay, so what this all acknowledging that the entire bathroom becomes a wet area. You have to take a look at those areas where typically, you might not be that concerned, but, where the water is going to be flowing into the drying area. And we're not talking about huge amounts. Realize over time, with different shower patterns and different shower usages, you don't want water getting up against these adjoining walls. Very critical you flash up, 3, 4, maybe 5 inches, just high enough. Water will never get past that, but you want to have a high enough flashing where there's no chance of water migrating into those stud wall cavities. We talked about slope to drain outside of the shower areas. And here we see where this could be a health club, it could be a sports club, it could be university showers, but we see a lot of showers, and we see, of course, linear drains running along the front of all of these showers. You see, in addition, there's a clamping ring drain because someone made the determination with this many people showering, there's a good chance water's going to get out further than you would normally anticipate. So it's almost like a backup, a safety valve, so to speak, to have this clamping ring drain placed well outside of the wet areas. Now, a couple things worth noting here. I think if you're looking at designing a concept like this, first of all, in California, you're not allowed to have the water flow into a common drying area like this. If you had curbless showers, which is I've actually been in health clubs that had this, curbless showers with just clamping ring drains run down the middle of this floor. In California, that's illegal. Why? Because, again, without getting too granular, imagine everyone's soapy residual gray water ponding into a central location and you're sloshing through it. Well, whether it's illegal or not illegal, it's kind of sort of a nasty image and experience to go through. So, it might be best in this kind of application to have linear drains on the back side of the shower, not where the curb was, to make sure everything's sloping away from this common drying area, this common pathway between the showers, and therefore alleviate those kind of concerns aesthetically. Okay, for some of you who are avid readers of the Tile Letter magazine, I recently wrote an article in the May issue about the explosion in use of these prefab trays and pans that are out there from a variety of manufacturers. And we're looking at EPS foam, which is expanded polystyrene, XPS foam, extruded polystyrene, molded expanded polystyrene, and then EPS hybrid products. Now, I think a large part of the listening audience might be aware of this concept, but in place of dry packed mortar beds in typical shower pans, we're seeing the use of these different foam products. They're already pre-pitched, pre-sloped. Sometimes they come in a kit form with a clamping ring drain or center drain or linear drain. But the idea is, for a variety of reasons, they're using this prefabricated pan concept to replace dry packed mortar. And just be aware, they are not all created equal. We'll go through, and it doesn't mean they're better or worse. There's just different ways each manufacturer approaches the market, okay? For example, with expanded polystyrene, think of styrofoam coolers, think of styrofoam cups. Of course, this is a much more commercially durable and resistant form of this type of styrofoam, but nonetheless, it's expanded polystyrene. It's typically wire cut into the necessary shape you want it, but not always. In this instance, we see where an EPS foam substrate, which is already sloped to drain, has a liquid membrane applied to the top of that foam to make it waterproof. Of course, this particular offering comes with the drain as well. There's also molded EPS foam. As opposed to wire cut, there's actually a mold of a certain length and width and height and pitch. Now, with this system, obviously, by the way, EPS foam unto itself is not waterproof, okay? So you have to cover it with something, whether the manufacturer covers it for you or you put a sheet membrane. In this case, that's what would happen. You would put your sheet membrane on top of this pre-pitched molded EPS foam template to create your waterproof environment. These come in a variety of shapes and sizes for both center drain locations as well as linear drain products. XPS, extruded polystyrene, is much more dense. It's a closed cell product. It is touted as being waterproof unto itself and more compressive, more resistant against point loading. And that is one of the concerns and issues you should be aware of when you're using these foam products. They are built differently. There may or may not be some point loading compression concerns, and manufacturers do try to make the installers aware of that. In this case, with the XPS foam product, an additional layer of cementitious product with a fiberglass skin is attached on the face of the XPS foam product to allow for more compressive strength and waterproof performance. So as you can see, and you're going to see, I believe, over the next 5-10 years, these type of products take a real strong percentage of the existing mortar bed systems out there. There are hybrid creations products out there where they're taking EPS foam that's wire cut and they're applying another layer of honeycombs matrix on top of it. The whole point to increase the point loading, compression, resistant characteristics of that foam product. If point loading and compression is a concern with some of these foam products, some manufacturers are taking steps as rigidity and stability picture, okay? But if you look real closely in your own home or in your client's home, would you want the carpeting and furniture quite that close to a shower with no curb? In reality, water is going to get probably into that area where this high-dollar carpeting is currently residing, and it may even get on the furniture. So you need to be really communicate with your client, whether you're a contractor putting this system in for a remodel, whether you're an architect or designer who's working with a corporate client. Oftentimes, these design whims can be a little unrealistic. In this case, I don't think you'd want to move forward on a long-term basis with this type of layout in your bathroom area. Okay, let's look at construction considerations. Whether it's going to be wood or concrete, that's going to affect your system, your process. Codes are very important. You want to make sure you're aware of all these codes. And by the way, if you don't feel up to snuff to address all these codes by yourself, you might want to hire a professional, a contractor, general contractor, architect, someone who can assist you in those areas. Budget concerns, obviously, what's the old saying? You can't build a silk purse out of a sow's ear. You want to make sure you have the money in your system to get where you want to go. Drain location, plumbing concerns are a big deal. And again, we looked at earlier, you may need additional drains in your drying areas depending on the nature and layout and number of showers you have that are curbless. So, again, substrate preparation, substrate choice, existing substrate there, whether it's wood or concrete, is going to impact your drain selection and location. Here, very important, the following Tile Council of North America methods readily apply to curbless showers: B421, B421C, and B422C. Now, because of time constraints, we're not going to show individual pictures of these details, but please realize you can go to your Tile Council of North America manual and reference B421, B421C, or B422C. These are all directly relevant to curbless shower details, okay? Additionally, and here's where the alphabet soup comes in, so please take note. You've got the International Building Code, you've got the International Plumbing Code, you've got the Construction Code, ADA, ANSI, of course, A118.10 bonded membranes, A118.12, that's your crack isolation performance, as well as mechanical engineer and IATMO concerns. I will tell you, IATMO PS106, part of those requirements actually touches on the compression, the compressive strength characteristics of prefab trays and pans. They actually take a steel ball and drop it from about 3 feet, and they see what kind of impact or damage it does to that foam tray. Currently, there is an ANSI standard in committee with regard to these foam trays and pans. They're still working on it, but hopefully in the future we'll have one of these, because that will allow all of us, contractors, distributors, architects, to identify good, better, and best. Can't stress strongly enough, jumping into a curbless shower takes a lot of pre-planning. Your drain selection, center drain versus linear drain, and then what type of linear drain, the suitability of your tile and stone. There's a huge, wide budget option out there for tile and stone, but you need to make sure whatever you choose is going to work based on dynamic coefficient of friction in your wet areas. I've seen where this happens, and it's not pleasant, where the owner wants that drain in a certain location X, and the plumbing is in location Y, and gee, no one knew there was going to be more cost to relocate that plumbing. These are all things to really be proactive before you start your project, so there's no surprises, there's no budget creep, there's no scope creep that is alarming to you or your client. And again, the waterproofing methods. A lot of options available depending on what type of drain you use, what your budget is, quite frankly. There's a good, better, best in this arena too, based on what you need and what you can afford. Obviously, there's residential considerations and commercial, and sometimes they overlap. you get into high-end hospitality, which is commercial, you might come across a very residential type of motif or design perspective. Conversely, if you're doing someone's residence, that may influence your choice of linear drain or clamping ring drain. You might not want something quite so industrial. Of course, form versus function, that's a constant challenge. You have to balance out what someone wants against what's practical and what can be actually achieved at a cost-efficient process in the field. And the value proposition of curbless goes well beyond just, gee, what does it cost for a linear drain? What am I saving by not having a curb? What's it going to cost for the additional membrane? There's a big holistic picture that takes into place health, safety, and welfare, takes into place what price you put on the aesthetic value of a happy homeowner or client or corporate client who loves the look of a large, continuous field of tile or stone throughout their bathroom afforded by a curbless shower. And obviously, these trends are constantly changing. Please be aware that it seems like every week there's a new linear drain manufacturer out there with a new bell and whistle. What might be practical for a residential project might not work very well on a commercial project. So in summary, curbless is a growing trend. And I think we made it clear, just because your shower is curbless, it's not going to be barrier-free. It can be if you adhere to all the barrier-free requirements. So be very careful if you're building a curbless shower or being involved in a project like that the client doesn't think they're getting barrier-free, okay? And a lot of considerations out there: drain type, drain placement, plumbing, coefficient of friction, waterproofing, of course, the alphabet soup of industry codes and standards. You know, from the top perspective, we're almost more familiar with how Council of North America details. We're more familiar with ANSI standards, but as you can see, these type of design considerations go well into other areas that you need to be well aware of before you get too far down the line. That's going to conclude my presentation part of the program. At this point, I think I'm going to turn it back over to Jim. And hopefully, if there's any kind of questions we can answer while we're all together on the line, we can go ahead and do that.
Great job, Dean. Appreciate another spectacular webinar with lots of information. I want everyone to note the telephone number down there and your email address. I did send out Tony's email information if you're requesting the CEU from AIA, and we do have a few questions if you got a minute. Our first question, Dean, is can you give a little bit more detail as to what barrier-free means? The person asking this may have missed the beginning of the program, I believe, but just real quickly recap barrier-free as opposed to curbless.
Excellent question. When you get into barrier-free showers, first of all, they may or may not include any tile or stone. Hopefully they do. But starting from a premise of if someone is in a wheelchair or in using a walker or even a cane, obviously it's more than just the curb being removed. They have to have access to the water valves. They need to have access to where they're going to get their potions and lotions. They have enough room in that shower to turn around adequately. So there's an ADA booklet that literally lists what the requirements are for a truly barrier-free environment. And the main message I had there was I've seen people and heard people who thought because they were taking the curb out, that was a barrier-free shower, and the actual requirements for barrier-free go well beyond that.
Great, great. Our next question is, how do you suggest performing flood testing without a curb?
Excellent question. I will tell you, and of course I'm going to hew to my area of knowledge, but for example, what I've seen done, if it's a liquid membrane with a sheet component used along with that, or if it's a sheet membrane, what they'll do is they'll build in a tag or a remnant that's large enough, long enough to actually turn up, and then they'll block that additional whether it was created with liquid and sheet together with a mat or a sheet membrane, it's actually flashed up. And then people have used sandbags, they've used temporary forms, but what they do is that creates that dam across the opening that can be used for the flood test. And then once the flood test is done, that tag or remnant is just then tied into the rest of the waterproofing in the drawing area.
Excellent. Here comes another good question. What's the largest size tile you feel comfortable with on a shower floor? And I think this has changed over the years.
Well, I mean, I think that, look, I've seen literally now where there are some manufacturers out there who literally they have whether it's a porcelain product or natural stone. I've seen pieces of flooring that were as large as the actual shower, almost a one-piece monolithic piece. So that can be done, but I think your dynamic coefficient of friction is really important. If you're going to do that, you better make sure that you're going to have the slip resistance you need to make that safe.
Yep, I was going to just say one piece is probably as big as you're going to find, and that new gauge porcelain tile panels and stuff, definitely. All right, next question. The shower door will have to extend all the way down to the top of the tile? Question mark.
Well, I mean, because essentially that curb is being pulled out, and you want to be able to easily open and close the door. But I think that working with your typical shower door manufacturer, I would imagine it would be at some minimal height to make sure there's no high points that would catch on the door. But I think that almost would be a matter of owner's discretion. The shower door placement is not going to impact the flow of water. It's not designed to do that.
Okay, great. So the DCOF is 0.42, if that's the threshold. Is it wiser to look for a DCOF above the threshold value?
Yeah, in most circumstances like that, I think to cover yourself, you would try to find, within reason, the highest DCOF reading you could get that was practical. I mean, we've all seen where in some cases you can get a tile or stone, or I should say a ceramic tile with so much abrasive quality, or maybe even a honed or variegated natural stone with so many high points and low points to create slip resistance that it almost becomes impractical. The tile or stone is hard to clean, actually functions as a catch-all for soap residue. So, there's a practical limitation, but I think the higher the number, the better, especially, if you're working in designing or specifying a project to cover yourself and your client against any kind of slip fall liabilities. Go for the highest number you can within practical considerations.
Thank you. All right, here's another question. If the shower floor is on grade, how do you get high enough by the door of the shower in order to slope down to the drain? In the past, we have floated up the bathroom floor itself to make a ramp. I'm referring to a barrier-free. Does that make sense?
Yeah, I think I've seen this. This often is a real challenge during remodels too, where you have an existing bathroom and you want to put a linear drain in, and you've got to create that slope to drain in the back of against the back wall. So by the time you get to the front wall, you've got maybe 1.5 inches, 2 inches of whatever you're using, prefab or dry pack mortar. Where practical, and that's the big challenge. Where practical, of course, it's a lot easier in new construction. If you can depress the slab to allow for that slope to drain, you're trying to create a scenario where you've got a minimal height change when you hit the front of that shower. In some cases, I've seen where to make it work, and it's a lot of extra money, people have had to flow outside the shower and actually, to make it a transfer point, a transition point that's realistic. They've had to go out to the drying area and actually put either additional substrate or additional dry pack mortar to make the heights standardized between the drying area and the wet area.
So real quickly, is your program, I know it's AIA accredited, is it IDCEC accredited?
Yes, it is. Yes, it is.
All right. So yes, everyone out there asking for your IDCEC CEU, it's the same contact I sent you for the AIA. Thank you. All right. Next question is kind of basically the same one. Just want to make sure we're answering them all, though. What is the best way to convert an existing shower on slab into a curbless shower? Raise the exterior slab or slope to shower door and then back down to the drain? Any information will be helpful.
Yeah, again, I think most times it's impractical to start asking a homeowner or a remodeling contractor to start taking or trying to depress the slab after the fact is going to be very expensive and problematic. I've seen if you were to put the drain where the curb was, you're going to have to slope from the back of the shower to that point where the curb was. But now you're also going to have to create some height outside of the shower area in the drying area with dry pack mortar. Any way you look at it, typically you're going to reach. And sometimes I have seen some thresholds out there, some graduated thresholds that can allow you to make that ramp up, so to speak, into the new height elevation created by that dry pack mortar. But in some cases, you may have to, if it's a concrete substrate, you may have to add some additional dry pack mortar to your floor details outside of the wet area in the drying area.
All right. Next question: is there a standard or minimum size of a steam room slip joint? Well,
I would say that when in doubt, always consult the Tile Council of North America EJ 171 details on that. They go through a variety of joint details, and I believe they also cover the steam room. I believe also too our company's steam room literature. I think most manufacturers of a waterproof membrane would also show you that detail. But I'm going to say this, Jim. I am on vacation in the Upper Peninsula of Michigan. I did not bring my TCNA Handbook with me, so I would just say consult the TCNA Handbook under EJ 171, and they would. And by the way, if this person wants to get a hold of me, message me. I'll be more than happy to give that information offline.
Okay, great. Let's see what else we have here. Let's see. We got 2 questions left. That's all we're going to take right now. How do you construct a curbless shower if the bathroom area and shower area are all on the same plane with no depression?
Yeah, as you can see, this is now. I'll tell you one thing. And of course, this
kind
is
of the same question over and over.
Yeah, but I just realized there's another possible option here. Now, I'm trying to make these answers non-product specific out of fairness to everyone. I will tell you that there are some linear drains out there. If you had a wood substrate, there are some linear drains that can allow you, based on their drain body design, where the bulk of the drain body can actually rest below the substrate, so to speak. Okay, so if you can just get that, so if you had a wood substrate, you can actually trace the base of the linear drain body, cut a hole out, and the lips or flange of the drain would rest on the substrate at 0 level, so to speak. That would greatly reduce the amount of dry pack mortar needed to get to the slope you wanted. I would also suggest, in most cases, I think you're going to have to see some sort of additional floor working be done in the drying area. I would also suggest take a look at the different prefabricated pans and trays out there. They're going to have different ways that they approach that situation, but unless you can get that drain body lowered, at a 0 point plus to the floor, you're going to have some significant pitch that's going to have to be achieved to get that slope of drain to your clamping or linear drain.
All right, great. Before I ask this next question, I want to thank everybody who's still on. for attending today's webinar. It was very informative. I hope you all learned something. Please look forward to your invite to our 2nd August webinar. And the reason I'm giving all this to you before this last question is because here it is. In August, do you like dry flies or streamers? And who is the better fisherman, you or Eric?
Well, Jim, since we're going to a very sensitive topic of discussion, I will tell you I was raised in the Upper Peninsula, and I was tying flies for native brook trout when I was 14 years old. And, these guys I know who are friends of mine, they kind of come by it late in life. They like to wear the nice gear and, have the nice fancy fly rod. But I'd say one-on-one in a stream up here in the UP,
I think you're going into way too much detail. Just give me the answer, you or Eric?
I'd say he's the better guy.
All right. Thank you, everybody. We really appreciate you attending. And invite will be coming shortly for a 2nd August webinar. Dean, you were fantastic. Great information as always. Thanks, everyone. We'll talk to you soon.
Thank you very much. Have a great summer, what's left of it.